and welcome to class. In this video we'll continue our study on bearing and distance, and in this video we'll be solving some problems on bearing. Okay, so we're going to be making use of cosine rule, because you apply cosine rule and sine rule and solving problems that deal with bearing. So we are going to look at some of the applications of that. So let's look at a typical bearing problem. Look at this. A village Y is 15 kilometers from a point X on a bearing of 025 degrees. Another village Z is 20 kilometers from X on a bearing of 115 degrees. Calculate distance YZ. Now, when you have problems like this, the first thing that you want to do is to make a sketch. So you turn the given problem, you sketch it out. Now, most times it should give you a triangle. So let's get to that. Now we have the equation that a village Y is 15 kilometers from a point X. So this tells us that X is the origin. So X is the point of origin. The village Y is 15 kilometers away from X. So when we want to draw it, look at what we're going to have. Alright, so you draw your pole. Remember, this is your knot. Okay, so going back to the question, a village Y is 15 kilometers from a point X on a bearing of 025 degrees. That means that from X, when you go 25 degrees from our knot, remember that is a true bearing, 025 degrees. So we'll move from the north pole 25 degrees. That should be something like this. All right, so this is a knot here. So we'll move 25 degrees from here. That should be something like this, and then we'll go up 15 kilometers. That is the equation. Let's go back to that. A village Y is 15 kilometers from a point X on a bearing of 025 degrees. So here is point X, 25 degrees, then you move 15 kilometers, you get to the point Y. Okay, so this is where we are now. This point here is Y. Let's go back to the equation. A village Y is 15 kilometers from a point X on a bearing of 025. Another village Z is 20 kilometers from X on a bearing of 115 degrees. That means that from the same point X, when you move 115 degrees, that should be from here. 115 should come into this quadrant. All right, because from here to here is 90. That's 90 that you have there. So 115 should come all the way down to this point. So we have this. So 115 degrees, and the village is 20 kilometers. So that is this. Let's draw it a bit further. 20 should be bigger than 15. So we have the town Z there, which is 20 kilometers away from X. This is 15 kilometers away from X. Back to the equation. Calculate the distance YZ. Therefore, we're looking for the distance between Y and Z. We're looking for here to here. YZ. This is what we're looking for. All right. Now, let's make sure we understand the sketch. We are told that a village Y, which is here, is 15 kilometers away from a point X on a bearing of 025 degrees. That means that from here to here is 25 degrees. Then we have that another village Z is also 20 kilometers away from the point X, still the same point X, on a bearing of 115 degrees. So we have 115 degrees for Z, and it is 20 kilometers away. That is why we have it here. Now we are asked to find the distance between Y and Z. So we're looking for from here all the way down to this point. That is how we come about. I will get this diagram. Now, how do we find our yz? So we're looking for this point here. Remember when we're dealing with triangles, if here is capital letter X, the side facing it becomes small letter x. Here becomes y. It's facing the bigger y. Y here becomes z. All right. Now, this is a case of your cosine rule when you have two sides given and an angle in between. This is cosine rule we're supposed to use here, but we need to find the value of the angle here. So how do we calculate the angle that we have here, the angle that we have inside of here? That is very simple. Note that from here to here is 115 and from here to here is 25. So for us to get what is in between them, 115 minus 25, so that will give us 90 degrees. That means that in between, inside of this triangle, what we have there is 90 degrees. Alright, so what we have to do is just subtract 115, the one that ran from North Pole down to 115 degrees, then the one that ran from North Pole down to 25 degrees. When you subtract them, you get the angle in between, which is 90 degrees. So we can then go ahead and apply our cosine rule. Our cosine rule in this case will be that, remember we're looking for x here. Alright, so our cosine rule, if we want to write it, will be that, okay, let me change that marker. So that would be that x squared is equal to y squared plus z squared minus 2yz cos x. That is what the cosine rule will be. X squared is equal to y squared plus z squared minus 2yz cos x. So we'll try to put in the values. X squared, we don't know what it is, so we'll still have a x squared is equal to now y squared. Y squared is 2, that is 20 kilometers, so we have 20 squared plus our z squared is 15 kilometers, that's 15 squared, because that's 15 squared minus, we have 2 times y, which is 20, times z, which is 15, cos 90. All right, so we continue. So we're having that x squared now is equal to 20 squared is 400, 15 squared is 225, and we have 2 times 20 times 15 times cos 90 now, but cos 90 is equal to 0. When you punch calculator, cos 90 is 0. That means that all this that you have here will evaluate to 0, because 2 times 20, 40 times 15, that's 600 or thereabouts, times cos 90, which is 0, everything will give you 0. So all that evaluates to 0, leaving us with just this one here. So we go ahead, x squared is equal to 400 plus 225, that will give us 625. Right, now for us to get our x, we take square root of both sides, so we're having that x is equal to square root of 625, and that will give us that x is equal to 25 kilometer. It therefore means that distance yz, the distance that we're looking for in the equation, that this distance yz, that is y is 15, that is from here to here is 15 kilometers. So this is a typical problem on bearing, right, where you have to interpret the given word problem, turn it into a diagram, and then you solve. Okay, let's look at another problem. Okay, we have this. A boat sails 24 kilometers from a port X on a bearing of 065 degrees, and thereafter 10 kilometers on the bearing of 115. What is the distance of the boat from X? Okay, let's try to interpret this in a diagram. So a boat sails from a port X on a bearing of 065 degrees, 24 kilometers. So let's look at that. So this is a certain point. This is point X, where the boat sailed on a bearing of, okay, let me make it a bit bigger. So we have this to be at point X, and this boat sailed from that point X 065 degrees. That's the bearing. 065 degrees, 24 kilometers. 24 kilometers, so we have 24 kilometers here. Knowing that here is 065 degrees, 24 kilometers to a point. Okay, so when it got to this point, 24 kilometers away from X, it got to that point. Now we are told that it then sailed 10 kilometers on a bearing of 155. It then sailed 10 kilometers on a bearing of 155. So if we interpret that, so at this point where the boat stopped after traveling 24 kilometers, we have another knot there, right? We have another knot, just like we have a knot here. Then from this point it sailed on a bearing of 155 degrees. So from here 155 should come into this quadrant, that is somewhere here. So it sailed then in this bearing how many kilometers? 10 kilometers. So it sailed 10 kilometers on a bearing of 155 degrees. So if we have this, it stopped at this point, right? So the question is now asking us what is the distance of the boat from X. So we're looking for the distance of this boat from X, and X is here, happens to be here. So we're looking for the value of from here to here. That's what we're looking for. So we have interpreted the problem. The boat sailed from point X on a bearing of 65, that's 065 degrees, to 12 kilometers. So you from here you move up to this point, then at there you have another knot. From there the boat made a turn 155 degrees and then sailed down 10 kilometers to a point here. Then we're looking for the distance between that point and the initial, the origin, the point of origin, that is X, where the boat set out initially. That is how we'll come about this diagram. So this is also a case of cosine rule, where we have two sides given and an angle in between, but we need to find the angle that is in between. We need to find the value of the angle that is in between here. Now let's find that. Now this is 65, here also is 65. That is there because they are alternate angles. So here is 65 degrees, here is 65 degrees. They are alternate angles. They are alternate angles. Now for here, remember that angle on a straight line, angle on a straight line is equal to 180 degrees. That means that from here to here should give us 180 degrees, but we already have a 155. That means that for us to get what is here, 180 minus 155 will give us 25. So we're having that what is here is 25. 25. Now all together, adding both, we have that the angle there is 90 degrees. That is how we try to so you always look for alternate angles. Here is alternate to here, that is why they are equal. They are 65 degrees. Then angle on the straight line gives us the remainder of this part to be 25 degrees. Summing them up, you have 90 degrees. So we're having this case. So going ahead to still use our cosine rule, you would also have noticed that since we're looking for this value here, if we call it A, if we're looking for this value here, the cos 90 is already will give us 0. Therefore when we multiply our 2 times this side cos 90, that will give us 0, just like we had in the initial problem. So this becomes a case of Pythagoras theorem. Alright, then we have angle here is 90 degrees. So it's like it's as if that we have something like this. We have here 90, we have here to be 24, we have here to be 10, and we're looking for here. So this becomes a case of Pythagoras theorem, because whether you use the cosine rule, you still get the same. So going ahead, we're having that a squared, let's call it a squared now, is equal to 24 squared plus 10 squared. Now a squared is equal to 24 squared, that will give us 576, and 10 squared would give us 100. So going further, you have that a squared now is equal to a squared is equal to 576 plus 100, that will give us 676. Now taking root of both sides, a is equal to square root of 676, and this implies that a is equal to, when we find square root of 676, that will give us 26 kilometers. So it then means that the boat at this point, is 26 kilometers away from its initial point, from the origin. So from here it moved 24 kilometers to this point, move another 15 kilometers to this point. Now it is 26 kilometers away from its point of origin. So this is a typical problem that we have on bearing and distances. So go over the video, try to go over the video and the solution, the problem and the solution and the interpretation. It is very important that you understand how to interpret a given problem. I'll be seeing you in the next video where we'll continue to solve more examples. For now, I'm going to drop an assignment for you. So I'll be seeing you. Bye.